So let me put this question up. So there it is. Okay, so we are trying to solve that question. So what are the coordinates at that point? Well, the x min and x max is negative 10, 10. So that means this line here is at negative 10, and this one here is at positive 10, because that's the x min and max, huh? And the y min is also negative 10, and the y max is positive 10. So it's 1, 2, 3, 4, 5 jumps from the center to get over to the 10. So how much is each of those jumps? Got to be 2, huh? So this is 2, 4, 6, 8, bless you, 10, right? And same thing going negative, negative 2, negative 4, negative 6, negative 8, negative 10. And the same thing going vertical. Each of them is 2, 2, 4. They can be different. They don't have to make the vertical the same as the horizontal. Real life problems, they're totally different units. Sometimes, time and distance or whatever, No rule that they have to be the same, vertical and horizontal. But they are on this one. They're all going by 2. So what's the coordinates at this point? Looks like it's back 6, up 2. Good on that? Easy enough? That? Yeah, you can't even tell in my picture. It's just number 1. Yeah, it's just number 1. All right, so they're talking to us about, they're wanting us to look at the region for the windows that would be appropriate for these points. So in other words, if you look at it, here's an x value, here's an x value, here's an x value, here's an x value. So the x needs to go from a low of negative 13 to the biggest x there is positive 5, huh? So you got to make sure you have an x range that would include, right? They're saying, hey, which of the window settings on the graphing calculator would be big enough to include all those dots? So you'd see them all in the window. Well, looking at those points, the smallest x value is negative 13, the biggest x value is 5. What about for y? What's the, for y, here's a y, and a y. The smallest y is what, negative 8? And the biggest y is positive 4? So as long as the y goes from negative 8 to 4 or more, it's good. All right, so would this window work first off?
No.
What's wrong with it?
X min isn't high enough. Right?
Oh, yeah, you're right. Yeah, that x min is too low, or it's supposed to go to negative 13. It doesn't cover negative 13, does it? Right, it's supposed to go all the way to negative 13. So no, that one's out. So no. Okay, how about the next one? Is that one going to work? Yeah, that looks good, huh? That one's good. How about this one? Yeah, because the negative 6 is not negative 13. And how about this one? Again, no, not negative 13. So the answer is B on that one. Good on that. So just finding a window big enough. So they're just setting you up with graphing calculator. Okay, so they're giving me the equation y equals x squared minus root x. And they're asking me, like, if the point 1, 0, and then a couple other points as well, we'll do them one at a time, is on the graph. How do you know if a point like 1, 0 is on the graph or not? They're not even showing me a picture of the graph. All they're giving me is that equation. How do you know?
Insert it.
Just plug them in. Yeah, you're just basically finding out if it makes it true or not, right? That's the membership requirement for any graph, right? The dots on that graph make the equation true, don't they? So you just plug this in for x and this in for y. So put a 0 in for y, put the 1 in for x, and you see if it makes it true or not. I think it does, right? 0 equals 0. Yes. So that one's a yes. The other ones must be no, huh? I mean, you don't really even need to go further. The answer must be A. We're done. But just in case you're wondering, let me do another one just to show you that is the truth. The other ones are not going to work. Let's do 2, 2. So take y equals x squared minus root x. Put 2 in for x, 2 in for y. So 2, does that equal 2 squared minus root of 2? No way. That's 4 minus root 2, which is not 2. So no. That one's a no, and you could do the other one. It's a no as well. So it's just answer A there. We good with that? Stop me if you want to talk about it. Otherwise, I'm going to keep moving rapidly along. Again, I'm going to go quick. So we'll look at number 13 here. So, all right, so it gives me this graph, this U-shaped, part of a sine graph, or I guess it's a cosine graph, whatever. It's got a trig graph. And they want me, what they're asking for is what are the intercepts? Yeah, there. List the intercepts. What are the intercepts? What are they talking about? What are the intercepts of a graph?
0 in and
What are, like if somebody's asking, what are intercepts? I mean, what are they? Where it crosses, huh? Where it hits the grid lines, right? So in other words, one of them's right here, one of them's right here, and one of them's right here. They want the coordinates of those 3 points, don't they? The places where the graph hits the grid lines, the vertical y-axis and the horizontal x-axis, huh? That's what they're asking me for. All right, so let's do it. What's the coordinates of that point? And coordinates mean two numbers, right? Over and up, x and y, right? So that point is what? Can you read it? It looks like back pi over 8, up 0, right? Or maybe, do they just want the x value? Oh, no, it says type an ordered pair. So it does. So it wants that, and then what's this one? What's the coordinates of that point? -6 looks like, huh? And then this one is pi over 8, 0. So you have to type those in just like that with commas between them. Is that making sense? Let me show you what I mean. Minus pi over 8, comma 0, comma. In any order, doesn't matter. 0 minus 6 and pi over 8, 0. Just like that. That's exactly what you type into Math Excel. Just like that. They have a pi button. When you go on to Math Excel and you go to type it in the bottom, they'll have a pi button there for you to click on to make the pi. They want the actual pi. They don't want 3.14. Is that good on that? Just finding intercepts. Graphing will be huge in our class. We're going to do a lot of graphing. We'll start here. So y equals x plus 2. What kind of graph is it going to be? Is it going to be a U shape? Is it going to be, what's it going to be?
diagonal line.
It's a line, right? It's what we call a linear equation. Now, why do we call that a linear equation? Because the picture's a line. How do you know by looking at the equation that it's linear? What makes an equation not be linear? What makes an equation have bending in it instead of just being a straight line? Higher powers, huh? If there was a 2 there, or a 2 there, or an absolute value, or even a 1 over x, or you start doing stuff like that. That's when you start getting curvature in your graph, huh? But if you just have a plain y and a plain, even if you have like a number in front, that's still going to be linear, straight line. It's only when you get powers or 1 over x or square root of x or absolute value, stuff like that, that brings in curvature, or v is absolute value. We'll get into all that later. But yeah, if it's just normal y, normal x to the first power, if x and y are just first power, then that's what we call a linear. This is a linear equation, meaning the picture is just going to be a straight line. And then that's easy once you know the picture is a straight line, because you only need 2 dots, huh? If we can just get 2 dots, we can get the straight line picture. Whereas that would not be the case for curves, right? If it's curves, you need a lot more than 2 dots to get an accurate graph. But if it's just a straight line, it's linear, x and y are just to the first power, then all we need is 2 dots. Now, there's lots of ways to do this. I don't care how you do it on a test. I never care how you do things, as long as you get the right answer. I'm going to show you I think the slope method's about the easiest. So, do you remember what that 2 is? On the graph? Yeah, it's the y-intercept. It's where you start. It's where you get your first dot. And if it's positive, you go up the middle. If it's negative, you go down in the middle. Remember that whole thing? It's the y-intercept. That's exactly right. So I'm just going to, plus 2. That means right there. Whoops, my little thing's not working. At positive 2 is the first dot. If that had been negative 2, then I would have went down 2 in the middle and put it down right here. Right? It's always on the middle line because it's the y-intercept. It hits the y-axis. It's where the line hits the y-axis. All right, and then so that's the first dot. I'm halfway there. I only need 1 more dot, and I can connect the 2 dots and make the line. How do I find my second dot? Remember the slope? What is the slope? Yeah, it's in front of the x. What's in front of the x?
1.
Yeah, it's really 1 over 1. That's the rise and the run. Since there's nothing in front of x, there's really an understood 1. 1 over 1, rise and run. Remember how that works? So from my first dot, I go up 1, over 1. There's my second dot. Now I can just connect the two dots. It's awful tiny. Can you see that? It went up 1 and then right 1. Up 1, right 1. Connect the two dots. We're done. We've graphed that straight line. So the first dot is whatever number is off to the right. Oh, by the way, all this only works if y's alone, huh? If y, they gave me a nice one that already had y alone. If y wasn't alone, you have to first get y alone before you can do this whole thing, right? So y's alone, you look off to the right. This is your starting number. It's positive, it's up in the middle, negative, it's down the middle. Put your first dot, and then whatever's in front of the x, whatever fraction, if there's nothing, it's 1 over 1. Up 1, over 1, rise, run. Put your second dot, and you got the graph. Let me show you how to do it on. So let's plot this point. Okay, so they're giving me y equals 2x minus 6. Now, we could graph it the same way we just did the last one, right? Except they're not letting me. On the test, I'll let you do whatever you want. They're being picky, and I'll have to do their thing. But normally, what would you do to graph this? It was on the test. What would you do to graph this thing? Where would you start? Yeah, start at down 6, right here. Down 6 in the middle, that'd be your first dot. And then you'd go, this is 2 over 1, right? You'd go up 2 over 1, put your second dot, you'd have the line. But they're wanting me to do a certain thing with x is negative 2. So they're wanting me to make a table, in other words, right? They're wanting me to say, let x be negative 2, find the y value that goes with. This is the other way to graph. I don't care which way you do it. On the test, I'm not going to make you do it one way or the other. You can do either way. So I've got to plug in negative 2 for x. What's that? Negative 4 minus 6? Negative 10. So it says plot the point for negative 2. They just want you to go back 2, down 10, and plot a point. And then they're going to probably give you another x value and plot another point, and it'll make the line. Is that good? I'm just going to do the first part of this one. The second part's the same. They'll give you some other x value, I'm sure. Questions on that? Is that good? What's the story with x squared? Do you guys already know that? What does an x squared graph look like? We have y equals x squared minus 10. What are x squared? Are they straight lines? No, we already talked about straight lines are just x and y to the first power. So this is not a straight line. What does an x squared graph look like? It's a U shape, a parabola. It's a parabola officially. It's a U shape, up or down. How do you know if it's up or down?
It's positive, it's up, it's negative.
Yeah, positive where?
X.
Right in front of the x squared, huh? Positive means up. If it was negative x squared, it would be down, huh? Yeah, that's right. So therefore, can you tell which of the multiple choice graphs it is? I don't even need to plug any points in. And that's all we're doing for now. We're just kind of getting your feet wet. We're not diving in the water yet. We will. In a week, I think next week we'll go crazy, and we'll do all kinds of graphs and get very, very detailed. Eventually, we'll have a whole section just on parabolas. We'll spend like a whole day, a whole 2 hours probably. We'll find focus points. We'll turn them sideways. We'll find asymptote lines. We'll do all kinds of crazy stuff. But that's later. For now, we'll go, yep, it's the one going up. That's it for now. So there it is. That's all they want for now. We're just getting... All right. Okay, so y equals minus x squared plus 10. And they're telling me x is negative 3. So basically, it's the make the table kind of thing, you know? Plug in x negative 3. So can you do that real quick? Can you plug in negative 3 for x there? And work that out and get a y value?
So just to refresh my brain, if it's negative 3 is x, then it would be like a negative and a negative, right? 'Cause it's negative,
Well,
like
yeah, that's the crucial question. You're right on. That's the issue. When you plug into a formula, you always put parentheses, and it really matters when you got negative signs. You're supposed to put parentheses around the thing you're plugging in. So let me do that. So negative. So in other words, here's how the plug-in should look. Everybody good to that point so far? So there's the minus that was already out there. That wasn't the plug-in, right? And then there was the minus 3 that I put in the x slot with parentheses. Now, why? Why do you got to do parentheses? Why did they make that rule? It's the only way to be true to the meaning. What I mean is just, for example, here's what I mean. What if somebody just said y equals x squared, and they wanted me to plug in x is negative 3? If I did not put parentheses, if I just wrote that, that would be technically wrong. Why? Well, first off, do you know what does negative 3 squared, without any parentheses, equal?
9.
Positive 9, I mean, we all know it's a 9, huh? Yeah, positive 9 or negative 9 is the issue. Positive 9 is this, and just this with this, no parentheses. Is that positive 9 or negative 9?
Negative.
Positive.
How many say positive 9? Making you vote today. How many say negative 9? Yeah, I'm with them. It's negative 9. That's a tricky little rule there. Did you know powers on a number only apply to that number, not even the sign in the front, unless parentheses extend their influence? In other words, what this really means is a 1 negative and 2 3s when there's no parentheses. So it's negative 9. Did you know that? It's a picky little rule. I know you think, well, no, that negative's on the 3. Well, it's separate. It's kind of like a negative 1 in front. It's kind of what it's like. So it's separate. Unless parentheses extend its influence. Like if you have negative 3 parentheses squared, yeah, of course, that's positive 9 because that's 2 negatives now. So it's positive. But the other way, it's not. It's only 1 negative. So everybody catching that rule, that'll come up again and again and again. You want to know that. So one more time. A power on something is only on that immediate thing, not even the sign in the front or anything else, unless parentheses extend its influence.
Even though 3 squared was by itself?
Even though what's that?
Even though the 3 squared was by itself?
Right here?
Yeah, even though it was by itself.
By itself? Yeah, it doesn't matter whether it's by itself or with other things. Am I answering your question? What do you mean by itself?
If you have a minus symbol in front of 3 squared, usually it has something in front of it, meaning the negative, you make it negative eventually, but because by itself with the minus 3, it still applies.
So what would not being by itself mean?
1 minus 3 squared.
Yeah, so that would still be 1 minus 9. Yeah, either way. Yeah, so I see what you mean.
Without
Yeah.
the 1, no
Yep.
parentheses.
Without anything at all. Yep. It doesn't matter. Yeah, that minus is not, it's separate. So the main thing you want to think is that minus is separate from the 3. It is separate. It's a separate item. So it doesn't do that. Yeah. So that's a tricky little rule. So that's why it really matters whether you put parentheses or not. So getting back to our question then. So this minus just sits out there. This one becomes a positive or normal 9. But then in the end it's negative anyway because of the negative in the front, but not because of the squaring. So in the end it's negative 9 plus 10. That's a long story to say it's positive 1, huh? So y is positive 1 after all that. We good with that? So watch out for that with squaring things. Okay, so I'm going to move on from that. I'm sure there's other points and other fiddling around, but you could do it, I'm sure. You guys got that? Oh, I'm going to... How do you graph when the y is not alone? So we've got minus 4x plus 3y is negative. So they want me to graph. It's just multiple choice, so we only have to go. In fact, you could already tell which 2 answers could it possibly be. Yeah, it's got to be one of these straight lines. It's not a U shape, right? Because x and y are just first power. So we know it's linear. We know it's a straight line. So just go ahead and solve for y, right? Let's solve for y, and then as soon as we get y alone, we can tell whether the slope's positive or negative, huh? We'll be able to know. So let's add the 4x to both sides. And so we get 3y is 4x minus 12 divided by 3. There it is. So what's the slope? Positive or negative? It's a positive slope, which means it's going up. Okay, so this one's going to be an x squared. So what's the general look of the graph going to be? Is it a line? Yeah, it's going to be some kind of U shape. So it's one of those 2 U shapes, isn't it? We just have to know whether it goes up or down. So what do you got to do to figure out whether it goes up or down? Can you just look right now and go, well, it's positive x squared, so it's going up? No. You got to get y alone. It's whether it's positive or negative after you got y alone. So we first have to get y alone, so that means it's going to end up negative, isn't it? So we subtract 2x squared from both sides. So all this, positive or negative stuff is after y is alone, both for the straight lines and for the U shapes. You got to get the y alone. Divide by the 9. And so there it's going down. It's a U shape going down because it's negative. So it's what? It's this one, huh? I don't even need to mess around with anything else. That's enough information. Because it's negative, it's the U shape going down. We good? There, so just get y alone, and you can tell whether it's going up or down.
Does the x have to come first in the equation to the right? Like when you move the x over?
Oh, do you mean if you had these reversed?
Right.
Yeah, no, no.
Matter or-
Yeah, it does. If you had like 18/9, or which is 2, huh? Minus 2/9 x squared. That's okay. I would still just look here and go, negative in front of x, going down. Yeah, so wherever it sits, just look what's in front of
Like on a
x.
test or something, you're not gonna, I mean, it doesn't matter what way we write it.
No, both those are fine. Yeah. They're asking for intercepts on this one, so we need to do that. So they're saying, okay, y equals 13x minus 20, and they want the y-intercepts. How do you find a y-intercept? What is the y? How do you find the y-intercept? What is the y-intercept? Yeah, a couple things. We already talked about a minute ago. What if we were going to graph that thing? What would we do first if I'm not going to. But if I was going to graph that thing, what would I do first? I would start where? Yeah, the number that's out here. Remember, whenever y is alone, y is already alone on this one, so we don't have to mess with the equation, huh? Y is already alone, so when that's the case, it's linear, right? X and y are just first power. So you start with the number off to the right, which is negative 20. So that means I'm going to start down 20. Right? Remember, it's negative, it's down the middle, positive, it's up the middle. So if I was going to graph, my first dot would be down here at negative 20, and then I would do the 13 over 1. I'd go up 13 over 1 and, make my line. But notice, what is this point? Yeah, that's a y-intercept. It's over 0, down 20. That is the y-intercept. They want the y-intercept? Well, there it is. Right? Do they want to... What do they want? Oh, they just want y equals. Yes, it's just y equals negative 20. That's all they want. They don't even want parentheses. How do I know? They don't say ordered pair. Notice in the blue writing, round to 2 decimal places, use a comma. They never say ordered pair. That's how you know when they want the parentheses and the 2 numbers with the comma. They say ordered pair. Not only that, remember, I don't know if I told you yesterday, if you're ever unsure on what they want on Math Excel, you know what you can. Yeah, so anyway, so getting back to it, so you can always just hit question help and show an example and enter, and get to the bottom, and you can see the format they want. So anyway, they just want y equals negative 20. So on this one, it's easy enough. But I like what you guys were saying. Let me address the other thing. A lot of you guys were saying set x equal to 0, and you're right. So if they didn't make this one so nice and user-friendly where y was already alone, I would need to do what you guys are saying. So let me just write that rule in general. When you want to find a y-intercept, you set x equal to 0. You're right on the money. So if I took that little equation, I mean, we already have the answer, but that's just because they made it so clean. If it wasn't so clean, I would have to plug in x equals 0, and then what would we get? 13 times 0 minus 20, which we already knew. So you find a y-intercept by making x 0. Why? Well, because look at this y-intercept point. X is 0 when you're on the y-axis, huh? When you're a dot on the y-axis of any graph, that means you're over 0, right? Your x is 0. When you're in the middle, right? You're not right, you're not left, you're right in the middle, your x is 0. So that's why that works. So if you want a y-intercept, you make x to 0. Now, on the next question, I mean, this same question, like part 2, they're going to say, find the x-intercept. So how do you find an x-intercept? You make y0, huh? Yeah, you always just make the opposite letters 0. Why? Well, because, like right around here is going to be the x-intercept. I don't know what that coordinate is, but whatever it is, it's over something up 0. It's x, y. Its y has got to be 0 if it's on the x-axis, huh? So if you're an x-intercept point, if you're on the x-axis, your height, your y is 0. So so those will go on through the class, not just right here, but we'll continue to have this as an issue. They'll ask us for intercepts of graphs. So you just want to have, even in calculus, you just want to have in the back of your mind, whenever you're finding intercepts, you set the opposite letter to 0. So y-intercept, make x 0, x-intercept, make y 0. And that's not just for lines, that's for any graph ever. That's always the case, because that's the very nature of what it means to be an intercept point. The other letter is 0, if you're on the axis, right? All right, so if I make y 0 then, if I take the little equation y equals 13x minus 20, and I plug in 0 for y right here, and then I have to solve for x, huh? So I'm going to add that 20. I'm totally running out of room here. I'm going to add that 20 over. And I get 13x. Divide by the 13. Can you read that? Sorta. 20 over 13.
This one says right decimals
Oh, yeah, you're right. So, bring it up here.
though. So using the calculator.
Yeah, so calculate it. So what would it be? 1 and 0.6 something? Anybody got it?
Probably.
54? So it is, thank you. Well, and two decimal places? Yeah, they want 2. 1/54. Yeah, thank you. Good on that? We good? So whenever you want to find intercepts, and that'll go on through the class, and even in calculus, opposite letter 0, because that for any graph, because that's what it means to be on a grid line. The opposite letter is 0. So graphing calculator time has arrived so soon. It's only the second day of class. So, this has to be solved with a graphing calculator. Well, not technically. So let me talk about this for just a minute. Did you know, so that's an x cubed equation, right? Everybody seeing that? X to the 3rd power. If that was just x squared, just 2 power, we could solve it, right? If it, x squared, how would we, so what if it was x squared instead of x to the 3rd? How would we solve it if it was x squared? How do you solve x squared equations? Well, yeah, if it just had x squared, huh? But if it has other stuff, like, if it has what? What if I just made the whole thing like the one that's there? X squared minus 4x plus 1 equals 0. If we wanted to solve that, how would we solve that? We can't, since it's got other stuff too. But x squared instead of x cubed. How would I solve that? What would I do? What do we do to solve x squared? Yeah, you try to factor, huh? I think that one wouldn't factor though, right? If you did like the parenthesis thing, x and x, yeah, just, what multiplies to be 1? Only 1 and 1, and that's not going to make 4 in the middle. So that one, a lot of them, if they factor, that's great, then that'll work. What do you do if they don't factor? Like that one wouldn't factor. We can still solve it though, right? What would we do? Quadratic formula, right? You use the negative b plus or minus. You're aware of all that? We'll do that. Well, soon, I think, maybe even next week. Then when it does not factor, use negative b plus or minus the square root of b squared minus 4ac all over 2a. Get a 3x5 card on the test. You can write that on your 3x5 card for the first exam. Anyway, we'll use it later, not tonight's homework, but sometime next week I think we'll start using that thing. Anyway, I'm just making a general point here. You don't even really need to write it down. We're not going to use it. But I want to just make the general point that if that was x to the 2nd power, we can handle it by hand. I mean, we wouldn't need a graphing calculator. We don't need technology. We could solve it by hand, try to factor. If it won't factor, use the quadratic formula. Either way, we can get the answer by hand. But it's not x squared. It's x cubed. So how do we solve x cubed? Is there a formula? Is there a formula for solving x cubed equations? Does anybody know? Yeah, the answer is yes. It is super, super hard. Really hard, like crazy hard. Here, let me show you. I've got it on my other computer thing here. I typed it in. No, that's not it. I was trying to get it. Right, there it is, the cubic. That's part of it. I went on Wikipedia. There's all kinds of sites you could go. Yeah, there is a 3rd power equation. Here's the history of it, and they're solving x squared. There's x cubed, and it's this whole big long thing. And then there's like a critical value. That's x squared. And then they come down here for x cubed. They have this delta weird. That's called delta. And then they got all these things, and they all plug in, and they become this big crazy thing here with arc cosine and all this mess. Honestly, I've never even used it. I got a master's, and I never did it. It looks beyond me. It's really, really messy and challenging and difficult. So it's super hard. So let's go. So my point in all that is to say yes, but it's hard. There is a formula I'm doing a little bit of history with you here, and I think that's important to know how it fits into the real world. I want to show you how technology and by hand math fit in the real world, what's really done. Formula exists for x cubed, but it's hard. But we can do it. So my point is you can do it by hand. You don't need technology for x cubed. We really could solve this if we were really good at math, using that messy formula and do it by hand. How about if it was x to the fourth? The story is no formula exists. Let me give a caveat. I could be lying to you right now, but I'm not meaning to if I am. It's either x to the fourth or x to the fifth. I forget which one. Starting at x to the fourth, it may be x to the fifth. So you can look at it in Google later, but you can probably find the answer now if you want to go on Google maybe. But anyway, starting at one of those places, there and beyond, let's just say it's x to the fourth. I think it's x to the fourth. X to the fourth and beyond, no formula exists. So what that means is, if somebody gives you an equation like, if they'd made that fourth power, x to the fourth minus 4x plus 1, you're doing something in the real world, engineering, architecture, science of any kind, and the thing you're working with ends up becoming that equation right there, which happens all the time in the real world, and x to the fourth kind of an equation when you're doing science in the real world, that can't be done. Not only do we not have a formula currently to do it by hand, it or any higher power, x to the fourth and beyond, we do not currently have a formula to do it by hand. We need technology. We never will have one. Now, what do I mean we never will have one? Am I just a pessimist? No, it's been mathematically proven that one could not exist ever. Could not be written in closed form using the symbolism system we use. Never could be. Isn't that interesting? I think that's an interesting area of math. You can prove, there's a whole area of math called existence proofs. You can prove whether things exist or not. For example, they've proven there's a solution to the game of chess. I think it's chess. I took game theory class. I might have things mixed up. It might be checkers or something similar. But I believe it's chess. There is an answer, but it's too hard for even the fastest supercomputer to crank it out. But it's been proven that an answer exists. There is a best way to play it, right? It's been proven mathematically that no formula could ever exist for x to the fourth and beyond. Right? It was proven by a guy named, what is his name? Galois. There it is. Galois. Galois proved it like in the 17 or 1800s. I can't even remember which one. Anyway, interesting little story. Can I give you 1 minute? I'm a wannabe history teacher, really. After I finished, I had this great history teacher. I used to hate history in high school. So boring, just dates and so dry. And then I went to junior college. I took Mr. Maglieri. He brought history alive. I thought, wow, history's interesting. It's people and events. Anyway, but it was too late. I was already way down the math science road. So I'm a wannabe history. Let me give you 1 minute of math history. It's kind of interesting, I think. Galois proved it. He was young, like 22, 23 for a math. Such a big state. He proved 200-page paper, gigantic, super hard math, way beyond anything I would understand. Really, really complex. Let's solve this thing by hand. Let me rewrite it. X to the third minus 4x plus 1. Okay, so x to the third. In fact, here, let me just re-paste it here. Okay, so there it is. So now, how do you do this I'm going to show you instructions for the TI-84, because that's all I know. But if you have a Casio or something like that, or this TI-84, it'll probably work for all the TIs. It's almost exactly the same for the TI-83 and for the 89. Well, the 89's fancy. It might be slightly different for that one. Anyway, I'll show you what I can. Let me show you this, though. If you're having any troubles, just go to YouTube, right? So let me show you what I mean. Coming over here. If you're having any trouble, see, I just typed in Casio solving equations. Look at that YouTube. I'm sure it's beautiful. YouTube is fabulous. You can do anything with YouTube now, right? I took the door off my truck, my daughter's truck, the other day. I don't know why there's an ad here.
People gotta make money.
You gotta wait. Okay, boom. Yeah, so there's somebody explaining how to use the Casio to solve equations. Anyway, so go on there and, if you have a different kind of calculator, just find it. Come upstairs. I'd be glad. I can probably figure it out. Yeah, in fact, I did. I did Casio a year ago with somebody in math, so it'll probably come back to me, and I can find the instructions, and I'll be glad to do that with you in office hours. If you have a different kind of calculator, I'm just going to show for the TI-84 right now, because I think I'll cover a lot of you. Could I use yours as a demo? Thank you. So I'm just gonna put this up on this thing here and go through the steps. Do a chunk of you have the 84 or it's some kind of TI? I mean, with you. All right, because I don't want to just be helping one person. Looks like I see a few of them. All right. So what just happened? There we go. All right. So. Are we going? All right, we're going. Perfect. All right, so there we go. So, turn it on. That wasn't on. Turn it on. All right, so first thing we need to do is you got to put it in Y1. So I'm going to write this out on the laptop in a second as well. All right, so go up here into Y1 and type in your function. What was the function? X to the third. So this is the X on the TIs, this X, tau, theta, whatever, This means any independent variable, basically. Any kind of, it can work for any letter in your equation. So just X. It always shows up as X. So even if they have a formula with T or whatever, just use that X. It's fine. X, and you know what, this is the power button right here, this up arrow. This is the power button on most graphing calculators. To the power. This is a nice newer one, so it actually shows the power. Some of the old ones just show the arrow. So X to the third. Type 3, yeah. So X to the third. Now I'm going to go right arrow, because I got to get down. So if I type right now, I'm up in the power zone. I don't want to be up in the power zone. So I'm hitting delete. So now I need to go forward arrow, and it comes down to the main line. And what is it? Minus 4x plus 1. Minus 4x, just use that big X key, plus 1, hit enter. So you see how it's highlighting the equal sign up there? That means it's got it. It's got Y1 in its memory banks, because that equal sign is highlighted. So there it is. Now what I'm going to hit is second, or not second, I'm just going to hit graph. See the graph key in the upper right for the TIs? Hit graph, and that's not my graph. So it must be in some other mode. No, that's the graph. Let me see, there's something going on here. Is it the stat plot? Yeah. I don't know if yours is doing something weird. Again, grab me after class. I can probably help you in 10 seconds. His stat plot is on, so I'm going to turn that off. I just went to second stat plot. That's what those boxes were. So I hit second stat plot, and I'm going to just turn this off. It's showing, I don't know how to do that. What do I do? Hit enter? Oh, yeah. And then go to off, enter, second quit. Wait, did I do that too quick? So you track with all that? So I just went to second stat plot. The hard part of the graphing calculator, the window. Yeah. So because you see, calculators are really very stupid. They're not smart. I mean, that's a dumb thing to do. Doesn't it know I want to see the graph? Well, it really doesn't. It's not smart. They're just fast. That's all they are. They just plug in millions of numbers super, super fast. But the graph is like over here, and the window's like way down here. So I'm like seeing nothing, or only like a little part of the graph. That's always the issue with the graphing calculators, is putting the window where the graph is. So you have to be the smart one. It's not true to say that technology just flies itself. It doesn't. You've got to be a good operator of technology, which is a lot of what we want to do. I want to teach you to do good graphs and work by hand, and also how to operate. Operating the TI-84 is a lot like operating software and things used in real life math science applications. It's the same idea. You got to be the operator. You do have to still be smart to know generally what the thing should look like, generally where the thing is. If you don't know that, technology is not going to do that all for you. You got to know that, and then direct technology to go do its fast thing, because all technology is fast. Okay, so in this case, it's the window. So I'm going to go to window, hit window, and see he's got some different windows set up. So I'm going to go. Isn't there a way to hit like standard? I don't know what it is. I'm just do it by hand. Yeah, I just go -10 to +10. I just make the X scale 1, -10 to +10. The Y scale is 1. Whoops, don't do that. Yeah, that's 10. Now, do you know that the negative is different than the subtraction on the graphing calculators in almost all calculators? It gets really upset when you mix those up. It seems so dumb. That's why I always say calculators are dumb. Technology's dumb. It's just fast. So, yeah, those are negatives, right? You guys know where the negative key is, at least on the TI? The negative is right here. Here's the neg down here at the bottom. This thing's true, right? If I go back to the original question here. Here's the question. It said, solve that equation. Don't give me a picture. Solve that equation. So how do I solve that equation? Let me draw what we've got so far. So step one, I did y1 equals x cubed minus 4x plus 1. Step two, I hit the graph button, and I got a nice little graph, which kind of goes, what does it do? It goes up. That goes up like that. Right? So there's my little graph, roughly, you know. So how do I use that graph to solve this equation? Do you realize that what they want is this dot, and this dot. Those three dots are the answers to that equation. Why? Why are those three dots? Just because they're x-intercepts? Who cares? Where did it say find x-intercepts? It didn't. Why do I know that those three dots, those x-intercepts, are the answers to this equation? Hint, hint, what does the equation equal? Zero. Right? And I put y1 on the left. So those are the places where y is 0, right? Remember I said y1 equals this thing, I told my calculator? And so where y is 0, this thing is 0. At this dot, whoops, I did something funny there. At this dot, and this dot, y is 0. So those, whatever those x values are, those are the places where y is 0. Those are the places where the equation is 0. Those are the answers, aren't they? So I have to find the x-intercepts. So let's go back to the graphing calculator now and find the x-intercepts. So how do we do it? How do we find those? Well, you do them one at a time. I'm going to do a whole process to find the left one, the whole process, same process to find the middle, and then again to find the third one. What is that process? Hit second, calc. See the calc up there that's above the trace key? Second, calc. Oh, by the way, you can't just move the mouse or the little left and kind of go on it and hope for the best. That's just an estimate. Everybody hear me on that? That's what students want to be like, well, I'll just move the left arrow, right arrow, and just go along the graph till I get there. That'll be close. That'll be an estimate, but it's not right on the money. You have to use the calculating features to get right on those dots. It's just an estimate when you move along the graph. All right, so hit second, calc, and I'm going to use 0. It might say x-intercept on your calculator or something different. It's to say a 0 is an x-intercept. Those are synonymous that we use in the math science world. A 0 of the equation is where the equation equals 0, so it's a x-intercept because y is 0. So a 0, an x-intercept, whatever you want to call it, that's what we need. Hit enter. It's saying, okay, you want to find an x-intercept. Well, I'll do it for you, but I'm going to search. The way the calculator does it, it searches. It's saying, give me left bound. See what it's saying there, left bound? Give me a spot left of it, and then it's going to say, give me a spot right of it, and then it's going to say, guess somewhere in the middle, a good place for me to start looking. We're going to go left of it, enter, right of it, enter, right on it, enter. So now what on what? The cursor. See the little thing moving along the graph there? See as I move right arrow, right and left? See that thing moving along the graph? So which dot am I trying to find? This one right here. It doesn't matter what order you do them in, but I'm going to start with this one on the left here. I'm trying to find that location. So number 2 has a little bit of a wrinkle. I think it's valuable to look at it. All right, so they have minus 2x to the 4th plus 9 equals 3x minus 1. All right, so if you're going to do the method, there's another method, and I'll show you another method. But if you're going to do the same method I did last time on number 1, what needs to be done first to this equation?
Solve for
K to 0. Right? Remember, it was all about equaling 0. Right? And it doesn't equal 0 right now. So if you want to do the method I just did, I'm going to show you a new method as well. So to use the method from last time, and I will give you a new one, but you don't have to do the new one. It's whatever you want to do. If you want to just keep using the one from last time, then you're going to need to jump these guys over to this side, right? They'll switch signs when they come over. Minus 2x to the 4th plus 9 minus 3x plus 1, right? When they jump over, just change signs. Is that okay? That too shortcutty? I just subtracted 3x and added 1 to both sides, basically. Gonzo, got a 0. You can combine like terms if you want to. You don't even have to. I mean, who cares? The calculator's going to take care of it all. But I'll do it anyway, out of old habit. So I'll just combine the numbers. So now, you got to get it equal to 0 first. So that's crucial. So if you want to do the method of last time, first get it equal to 0, and then it's all the same. Now it's, y1. Well, let me squeeze it over here. Now you do, y1 is minus 2x to the 4th plus 10 minus 3x. It doesn't matter that I have it out of order. Calculator can handle all that just fine. And I'll just go dot, dot, dot. It's all the same as last time. But you got to first get a 0, right? Because we found zeros, didn't we? We found places it was height of 0. So you got to first get it equal to 0. Or there's a new method, which you might prefer. And that is, if you don't want to mess with the equation and get it equal to 0, what you could do, let me write it out here. In fact, let me change up my color here. All right, so what you could do, you have minus 2x to the 4th plus 9 equals 3x minus 1. The new method is you could say, look, this is y1, this is y2. Enter them as y1 and y2. And now you're going to find where y1 equals y2, not where anything equals 0. So you go to your calculator. So that'd be step 1, actually. Let y1 equal this, and let y2 equal that. That's step 1. Step 2, graph them. Step 3, it'll ask you, what's the first curve? You just hit enter. What's the second curve? You just hit enter. You're graphing two things on the screen at once. And then guess, you move near, I skipped a step, sorry. Let me back up, I'm going too quick. You got to hit the intersect button, I forgot. All that comes after you hit the intersect button. So step 3 should have been hit intersect. Well, second calc, intersect. Yeah, let me keep changing my mind here. Second calc, and then intersect. So you find the intersection instead of the zeros. And then step 4 will be what I was just saying. It'll say first curve, and you hit enter. It'll say second curve, you hit enter. And then it'll say, and then you guess near an intersection point. You guess near an intersection. Can you read that down there? You do first curve enter. I'll show it on the screen in a minute. First curve enter, second curve enter. Guess near an intersection point. So in fact, so you guess a point of intersection between the two graphs. All right, so let me show you. All right, so this thing's back on. Yeah, I'm going to do the y1, y2 method. So I'm going to go back. So I'm going to put in y1, what was it, minus. Again, use the negative, not subtraction. It'll get really upset. Minus 2, is it plus 9? Yeah, plus 9, thank you. So that's y1. Y2 is 3x plus 1, thank you. 3x minus 1. So is that good? So I put in y1 and y2. I'm using the new method. This is a little quicker. You might prefer this. And you can do it even if they equal 0. I don't have to make them equal 0. But you could have done it even back on problem number 1 and just made y2 0. Because that is the right side. And you'll like this probably a little bit better. And then you go to graph. Next we hit the graph button, right? It's going to graph both graphs, y1 and y2, because both equal signs were highlighted, right? So graph them both. And we're looking this time not for the zeros. Nothing equals 0 here. But where they intersect each other. Where they're equal. Where y1 equals y2. Where left side equals right side. So that would be these 2 points, right? See this one right here? This point right there is a point of intersection. And then this one up here is a point of intersection. I want to find those 2 dots. So how do you do it? Well, you go second calc, but instead of doing 0 this time, nothing's equaling 0, I'm going to do intersect. Hit enter, and it's saying, okay, what's your first curve? So this time it doesn't do a left-right guess. It does a first curve, second curve guess. And that's easier because see how the cursor is already on the first curve? It always will be. Just hit enter. Don't even move it or think about it. Then it says second curve. We'll see how the cursor already is on the second curve. It always will be. Don't even think about it. Enter. That's why I'm just saying enter, enter without even a thought. And now it's saying guess. So now for the guess, we'll have to do them one at a time. You move near, because that's where it's going to start searching. You move near one of your intersections for the other one. So let me actually show that. So what did the graph actually look like? The graph was a U shape going down, and it was a straight line kind of going like that. And we're finding those 2 points of intersection. So again, I did Y1, left side, Y2, right side, step 2, graph, step 3, second calc, intersect, and then step 4, you have to, what was it? Oh, first curve, it asked you first curve, you hit enter, second curve, enter, and then the guess, you move near point of intersection. So we found this point. What is that? X equals negative 1.65. Oh, yeah, it's right up there. Negative 1.65. I don't even care about the y value because the original equation didn't have y's. It just had x's, right? So all I care about is the x. And then find the second one. Just do the same thing again. Oh, I'm not showing you what I'm writing, huh? Sorry. So I'm just going to start again. I'm going to hit second, calc, go down to intersect, hit enter, first curve, enter, second curve, enter. Now, guess, go near the other one. Boom. There's the second. 1.32, it would round. So I'll go back to, here's what I was writing, even though you weren't seeing it. I was just talking to myself. 1.32. So there's just the instructions again. So there's the other method, which is probably a little quicker. You don't have to worry about left and right and all that. You just go enter, enter, and then guess. And you got it. Make sense? Good with the graphing calculator? Solving things? Again, for Casio or others, use a YouTube, come by office hours. I'll be glad to help you with that. All right, I'm going to move on. I don't know if you got all that copied down. It'll be on YouTube. All right, so now we're solving stuff by hand. Remember on the next exam, or the first exam, which I guess is the next one, it's going to be part 1, no graphing calculator, and part 2, where you can use your graphing, because you need both skills. So, so these will have to be solved by hand on the next test. This will be in part 1. Be a couple questions like this. Can you solve that by hand from your algebra days? Thank you. So go ahead and give that a try. What do you do first on that one? Common denominator. Yeah, so what's the common denominator? 45. What do you do with the common denominator? Top, 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 right? 45, 45, and the right side, because we got to have equal treatment. If they were equal before, we treat them the same. They're still equal, right? Everybody good with that? This stuff matters a lot. This is the stuff that makes people not pass calculus, especially. It's all the algebra mess. This is more important than that graphing calculator stuff. Getting all these down. I know you've all had this, but getting really, really comfortable with it because it's just all over the place in calculus. Cross cancel, right? 9 goes into 45 5 times, and then the leftover multiplies. So what does that make? 5x plus 15. Then bring down that plus sign. Everybody track with that first fraction, how I handled that.
So do you have to put that in parentheses, that equation?
No. Everybody see what happened there? So I found the 5 and 9 common denominator, multiply together, 45. And then I put that top, and then cross cancel. 9 goes into 45 5 times, the leftover 5. So you cross cancel, and whatever's left over multiplies. Remember all that? All right, try that next one, try that next fraction, do the same thing. And then go on and solve it from there. So 5 into 45, 9 times boom, boom, right? 9x plus 27, and that's 45. So remember, common denominators cancel things, don't they? Right? I teach algebra all the time. I have a lot of people that will forget that, and they'll let the 45 actually multiply they'll use the 45 and they'll multiply the x and the 3. Don't make that mistake, right? So I make up goofy sayings to help them remember. And for this one, common denominators are hitmen. What do they do? What do hitmen do? They take people out, right? Well, that's what the 45 is supposed to do. Don't forget that. Let him do his job. That's what common denominators always do, is they take something out. So you let them cancel, right? And then the 9 is what distributes, right? So you won't make that mistake. All right, and then from here it's easy. Once the fractions are out, it's cake, isn't it? 5x, 9x, what's that, 14x, 15 and 27 is some number. 42, thank you. 45, and then just subtract the 42, like that. 14x is 3, divided by 14, and we got it. I don't know if they want a decimal fraction. On tests, I don't care. So there we go. Good on that one. You remember those steps from algebra? Please ask. That's what I'm anxious to help you with, because that's what you really need for calculus. Because calculus, like every problem, has tons of this, and you got to be really, not just sometimes get it right, not just 7 out of 10. You got to get, you got to get 99 out of 100 times to be able to do that without a mistake. To not be frustrated in calculus. All right. I probably should have not spent so much time on that graphing calculator, because this is more what you need. Okay, so let me just give you a game plan. X squared with an equal sign. You want to have a sure, clear, clean, right away knowledge. Step 1, get a 0. Whenever you have x squared with an equal sign, you just want to automatically know. Get a 0 is step 1. Step 2 is try to factor, like with the parenthesis kind of thing. And you do need to be comfortable with factoring here and in calculus. And then if it won't factor, or if you just don't want to, you don't have to factor in this case. There's other times you have to factor, so we'll talk about that. Then use the quad. Negative b plus or minus. So maybe you do need the quad in this homework. I said you didn't, but I could be wrong. Negative b plus or minus square root of b squared. We'll see as we solve it. I don't even know right now. Minus 4ac. So write that down. That could be necessary if it won't factor. So there's the game plan for whenever you see x squared with an equal sign. There'll definitely be one of these on the next exam. Get a 0, try to factor. If it won't factor, then use the quad. You put that in your 3x5 card for the next exam. All right, so let's do it. So we have this x squared. So I'm just going to jump these guys to the other side. Is that okay? They just switch signs when they jump over. Really, I'm just subtracting 20x and subtracting 32. Right? So there's the wall equals 0. Well, I'm running out of room. Let me get that out of there. So we get 3x squared minus 20x minus 32 equals 0. Now we could try to factor that thing. I don't know if it factors. Here, let me move to a new page. I'll rewrite it up there. 3x squared minus 20x. Everybody got that copy down? I'm going to move to a new page. 3x squared minus 20x minus 32. 3x squared minus 20x minus 32. Okay, so I'll try to factor it. I don't even know. I don't know how you factor. Anyways, fine with me. I just do the guess and check thing. So 3x. I write FOIL because first times first, front times front is front. I'll go slower. I wish I could go slower. Over factoring maybe later. I'm glad to help you in office hours. I know a lot of people are rusty in my experience in teaching this class. A lot of people are rusty on factoring. You need to get more and more comfortable. I'm glad to go over it with you in office hours and stuff. I'll do what I can in class. So front times front to make front. So far so good, right? And now I need last times last to make last. What times what's 32? Well, there's a few options. 4 times 8, 2 times 16, 1 times 32. How do you know what you want to do? You guess. But guess with wisdom. It's usually the numbers closer together. So it could be 4 times 8. Whoops, that doesn't look like times. 4 times 8. It could be 2 times 16. It could be 1 times 32. I try the pairs closer together first off. It's usually those, but not always. There's no hard, fast rule. Maybe it's 4 and 8. Is it? Yeah, actually I got lucky. Let me reverse. Let me not get lucky the first time and reverse it. If I did 8 and 4, that's wrong. How do I know? Well, I'm working out the middle in my head right now. Let me show you. 2 inner, 2 outer. That's the O and the I of the FOIL. Do you remember all this? I know a lot of people are rusty on this. Inner times inner. What's that? 8x. Say I'm doing the I here. That's the FOIL. O and I stand for outer, outer, inner, inner. Outer times outer. What's 3x times 4? 12x. Can 8x, no signs yet. Notice no signs yet. Hold off on the signs. Can 8x and 12x add or subtract or do anything to make to make the middle? O and I is supposed to make the middle minus 20x. No way. No way. So that's not right. But now what do? Reverse the back 2. Do you remember all this? Now you'll probably just prefer me to do the quad, which I'll do in a minute. But I'll show you this. So I reversed the back 2 because I'm trying to get the middle right. Is everybody tracking with me on this? Right? The front times front, 3x times x, is the front. And last times last, 4 times 8 is 32. Don't worry about the negative. We'll do the signs in a minute. Hold off on that. I'll make it negative 32 in a minute. Right now it's just 32. Right? But the middle's always the pain because the middle comes from 2 things. O and I. The oi. Right? Outer, outer, inner, inner. So let's try the outer, outer, inner, inner thing again. Is it working now? Yes, now it'll work. Do you see it? Inner times inner is 4x now. Outer times outer is 24x now. Can they make minus 20? Yes, they can. If you make this guy positive and this guy negative, they will make your minus 20. The sign in the middle, let me give you this hint. This is a big, important step. The sign in the middle, which is what? Negative on this one, always goes on the bigger of these 2. Okay, great. So right, the 24 is bigger than the 4. So the sign in the middle is negative. So the sign on the 24 is negative. The sign in the middle is always taken by the bigger one, right? Because he's more negative, he makes that negative 20, right? And then how do you know where they go up there? The top one always goes straight up, right? Because that's on the 4. This goes right there like that. And the bottom one goes to the back. So there it is factored. That's a little painful for a lot of people. So after you factor it, what do you do then? You set each one equal to 0 separately, right? Why? Why do we do that? Why do we make 2 equal zeros when we only had 1 equal 0? You've seen it before, huh? But do you know the reason why? I hope it's not just because some math teacher said so or some math book. Why can you go from 1 equals 0 to 2 equals 0? Why is that okay? Was there 2 separate? Why? Why can I make them 2 separate? It was 1 equals 0. Why is it okay to make it 2?
Because if you know those equal 0, they're going to multiply together and will equal 0.
Yes. Do you know the logic? Math is logic, right? And if you tile into the thinking, it'd be way easier. If I said, hey, I'm multiplying 2 things, and it's coming out 0, what does that mean? If I'm multiplying 2, if I say I'm thinking of 2 numbers in my head, I'm multiplying them, and the answer is coming out 0. What does that mean about my numbers? Either one could be 0. One of them's got to be 0, huh? If you're multiplying 2 things and the answer is coming out 0, the first one could be 0. 0 times anything will be 0. Or the second one could be 0. Anything times 0 will be 0. That's why that's logical, right? These are 2 things multiplying, right? This parenthesis is multiplying that parenthesis, and it's coming out equal to 0. So that means the first one could be 0 or the second one could be 0. It's just reasonable, isn't it? All right, and then finish from there. Subtract 4. 3x is minus 4, divide by 3. Move the 8 over. I'm just going to skip a step. Positive 8. So there's our answers. Negative 4/3, positive 8. Having done all that, I bet you don't like that very much, and you'd prefer me just to do the quad. So I'm going to redo that with the quad, if you don't mind. I'm going to change pages. If you didn't get it, it'll be on the YouTube thing. So 3x squared minus 20x minus 32. So 3x squared minus 20x minus 32, right? So now I'm going to do instead with now it did factor, but that was kind of painful factoring. That was pretty hard factoring. There's a lot easier factoring than that. That was pretty tough factoring. I know that's hard for a lot of people. I think you would probably enjoy the quad a little bit better. So I'm going to do the quad now. This is always an option. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm doing this instead of factoring. So I'm redoing the problem. We've already got the answer. If you're a good factorer, great, you can do the factoring thing and you're done. But I found that a lot of people are rusty, and we'll help you improve that throughout the semester, but you might prefer just to use the quad at this point. So I'm going to go negative b, and what is b? B is itself negative 20. So negative 20 plus minus square root of b squared negative 20 squared minus 4 times a times c all over 2a. Remember using the quad from your algebra days? All right, so we plug that in. Roberto, you're here, and
Yes.
I talked about you in the beginning, and now
I'm running in here.
yeah, I'm running late. I mean, I know you need some time, huh? All right, and so I just squared that negative 2400, and this is negative times positive times negative, so 2 negatives is going to be positive. Remember all that quad stuff? What is that? Somebody got that? 12 times 32, 320 and 64? 384? 384, right? All right, so, and then the next one, and then just keep cranking that thing, 20 plus or minus the square root of 784 over 6. 784 has a nice root. Right? Tell me it's rootable. What's the root of 784? It's got to be clean. 28, beautiful. 28 all over 6. I'm running out of room. You guys got that down? I'm going to change screens again, unfortunately. I should have squeezed this in a little bit more. 20 plus or minus 28 all over 6. We okay with that? Here, I'll go back in a minute. 20 plus or minus 28 all over 6, right? Is that what it was? You guys got that copied down? 20 plus or minus 28 all over 6. And so then you just do the two options. That's 20 plus 28 over 6 and 20 minus 28 over 6, which is 48 over 6, which is what, 8. And this is minus 8 over 6, which is minus 4/3. The same two answers we had by factoring. So I don't know. Most people prefer the quad. Did you get all that down? Let me go back. It's probably the easy screen for you. Back to there. You guys get all that copied down? So that was a pain.
Okay, so when you did the negative b plus minus, so that made it positive, right?
Right.
Okay.
Yeah, right, because it was negative in the formula and negative on the b, so two negatives made positive. Exactly.
So when you put that negative
Right.
20 into that square root, it has to be in parentheses, right?
Yeah, everything we plug into a formula is always in parentheses. Yeah. We good with that?
But the square is outside, whatever.
What's that?
The square root is outside of that. I mean, it would be negative 20x and negative 20x, right? For the square root part of it. Well, I don't know what's happening. I forgot how to do the quadratic.
Yeah, that's okay. Grab me after if you want to talk more about that.
About ECC, you don't know what the sections are.